Thank you for the introduction. Great to see everybody join. So as I get started, of course, if you have any questions or any thoughts, feel free to just pop them into either the chat and or the Q&A, and I'll do my best to kind of get to them as we go, or just keep them to the end, depending on the question. So I'm sure all of you have been attending all of the great sessions so far, so you're pretty familiar with YOLO v5, either by having used it before or just hearing all about the speakers. And so really what we're going to be focusing on today is a little bit more about quite generally how you can debug a computer vision model, specifically a computer vision model trained on YOLO v5, and how you can do that within the Comet platform as well. So as a little bit of an introduction, so I'm Jacques, head of product here at Comet. So Comet is an MLOps platform focused on experiment tracking, model registry, as well as monitoring your models in production. So you can kind of think of it as monitoring all of the machine learning lifecycle. And prior to joining Comet, I was actually building and deploying real-time machine learning models, both in the fintechs and B2C space. And I actually worked quite a bit on a computer vision model and even used YOLO v5 back when I was building the first iteration of that. So really excited to be chatting about all that today. So really the way I tend to think about it is when you're training a computer vision model, the hyperparameter optimization is just a really small part of the training process. There's a lot more that goes into training computer vision models beyond just hyperparameter tuning, either through, let's say, a grid search or something a little bit more optimized like Bayesian hyperparameters. There's a lot more that you need to do, and that's all of those are things that you can do within the Comet platform. So maybe one of the things I always do when first building a machine learning model is the first thing you need to do before you even start debugging a model is you need to actually debug your training data. Your model is only as good as your training data, and collecting a lot of data for a computer vision model tends to be a really complex task. And so you need to be able to track all of the data that you've collected and all of its different versions, right? You're going to start with some data augmentation at the beginning, and then as you start to make the model more and more complex, you might add more data augmentation steps. And so you're going to have to keep track of all the different versions of your model. And then you need to be able to visualize and debug that data itself. And so that's kind of usually the first step. A little bit more on the data analysis side, but what's really interesting about computer vision is you're only ever going to be able to visualize a very small portion of your data set, maybe 1,000 images if you spend a couple of days on it. You can't really summarize the data, and so we'll see how you can use the actual training process to be able to find some issues with your training data. Once your training data is in good shape, the actual images you're going to be training on, you do also need to take care of your labels. So in a lot of cases for computer vision applications, you're going to be using manually labeled data. And in that case, humans are always prone to making some mistakes, either because something isn't clear or because you're just labeling a lot of data, but that can cause a lot of issues into your training process. And so one of the things I always do when I've trained my first model is try and identify the data that has been potentially mislabeled and just send that for another labeling step or pipeline, just to get that extra confidence that all of my labels are very well labeled. And so then we have, once we have our training data and our labels in really good shape, then we can go to our model architecture. And so this is where we'll actually start tweaking the model architecture to be able to get the best model. And that's where we're going to be looking at the performance of the model. Luckily for us, YOLO v5 has 4 or 5 different model architectures, from very small models to very big models. And so we'll see how we can go about choosing the best model architecture for our application using the Comet platform. And then finally, you can you kind of start optimizing the model architecture that you've chosen to extract the most performance out of it. And so that's when you can start playing around with hyperparameters and start seeing exactly how your model behaves based on some of the tweaks you make to your hyperparameters. So those are the 4 main things that I always do when I'm debugging a computer vision model, and also kind of visualizing the performance of a model. And so kind of start with your training data, move on to your labels, then model architecture, then hyperparameters, and then you kind of start that loop all over again, where you you're continuously updating and optimizing your training data. So before we jump into a demo within the Comet platform, just kind of wanted to give you a quick take on how easy it is to be able to access all of the information I'm going to be showing you within the demo. So the only thing you really need to do is just pip install CometML, really simple. Go to comet.com, create a free account, and then just pop in your API key here in your terminal, and then just train your YOLO v5 models as you would previously. And so that is, we have a very tight integration with YOLO v5, and so we'll be able to pull in a lot of the information I'm going to be showing just out of the box for you, so you can start really understanding the model training process in a lot more detail. Awesome, so let's jump into a quick demo within the Comet platform. So as I mentioned, Comet helps you monitor and track the entire life cycle of your machine learning model. And so that tends to be, that splits up into 4 main parts of the platform. So we have Comet Artifacts, which is used for dataset management and versioning, which is where we're going to start off and where you can do a lot of that training data analysis. We then have Projects, which is more for experiment tracking and experiment management. You then have the model registry. Once you have your model trained with, and you think it's going to have good business value, then you can add it to the model registry and start sharing it more widely within the business. You can even use our webhooks integration to deploy that model. And then finally, we have model production monitoring, which is used to actually monitor your model in production. So from there, you can see that kind of end-to-end monitoring from training all the way to production. And when you do retraining, of course, all of that can end up being captured within the same platform. So we'll start off with kind of the first step that we had mentioned around debugging our training data. So here we can see we have our YOLO v5 data set. It has a bunch of different versions as we were iterating over that model and finding the one that was going to perform best by trying different data augmentation strategies. We have a number of images here, and so we can preview them and just see, kind of get a good idea of what our data set looks like. Of course, you will not always want to host your data set on the Comet platform. And so we do have a tight integration with S3 or GCP that also allows you to keep your data stored in S3, but actually have all of the lineage and tracking of which training run used what data within the Comet platform. And so that's called remote artifacts, if you want to look it up in our documentation. And so you don't necessarily have to upload the data to Comet. But let's jump to lineage. We can see here we have our version 17 of the data set. And what's really interesting is we can see that version 17 was actually created from version 16 of our data set in the helpful damper kind of training run. And so here, if we click through, we can see all of our data augmentation strategies. And so really you have that full lineage for your data set. And then we can see all of the different experiments that were trained using this data set. And so this becomes a really neat way of kind of knowing which data set version was used to track which experiments. So let's go to comparable bracket here. This is one of the experiments that was trained using version 17 of the data set, and we'll jump straight into experiment tracking. So what we're looking at here is what we call our single experiment view. Is we've trained one model, and we kind of want to see how the training process went, how well the model is performing, as well as some other kind of really interesting information. So big thing that I want to kind of call out is, as we saw earlier, the only thing you need to do to be able to access and get all of this information is simply install Comet and add your API key. So everything else has been instrumented within the YOLO v5 kind of library, thanks to the YOLO v5 team and some of our internal team as well. And so all of the metrics here are going to be captured out of the box. And you can see here that we're capturing a lot of information, not just on the training data set as the box loss here, but also on your validation data set, where you have your class loss, you have your recall, your metrics. All of this information is going to be captured. Here we can see it as a function of step. we can also have a look at it as a function of epoch. Here we did just 5. But as you can see, when your model is going to be training for very long periods of time, you're going to be able to track and manage all of the different metrics that are being computed so that you can know, okay, maybe my validation data set, my recall, for example, is starting to increase. Let me stop the training run. Let me start a new one, try some other hyperparameters. So everything that you see here is kind of updated on the fly in real time as your model is training. We're also capturing all of the different hyperparameters. And so this becomes super useful when we think about reproducibility and being able to really understand why one model performs better than another. So we have the great thing about the Yellow v5 library is super customizable, right? You have all of these different parameters that you can change either through the command line or the config file. And so we capture all of those so that when it comes to comparing 2 different training runs, we can actually diff all of those value. And when you have both hyperparameters and the training data, both of which are kind of tracked within the Comet platform, then you're able to get that full reproducibility. There's a number of other data that we capture, like all of the metrics that we talked about, installed packages, system metrics, a bunch of other things. But really what I wanted to focus on are all of the images that we can capture. So we're talking about computer vision models. This is what kind of Yellow v5 is used for mostly. And so what we'll be looking at here is some of the data that is captured. And I can see a question coming in already. So that one's quite a big one. So I'll get it to the end. I'll keep it to the end. So we can take a look here at our precision recall curve. And again, this was captured automatically. And so we're able to kind of keep track of all of this information. It's never stored locally. You don't lose it. It's always associated with a set of hyperparameters, a set of training data, all of that captured within the Comet platform. As you can see, we're also tracking some of our training data, which we'll see in a second. So that kind of gives us a good idea. We also have here the confusion matrix, which is logged as an image, which is super useful, but we actually have a specific view for confusion matrices within the Comet platform that kind of allows you to have a little bit more of a deeper view. So what we'll do is we'll look at the percentage by row, and this is going to give us a really good indication of which label has been misclassified. And what we would expect to see is we would expect 100% along the diagonal. That would mean that all of our images are correctly labeled, all of our boxes are correctly labeled. And so we can see that that's not always the case. And if we take an example here on the cat, we can see that, well, we are correctly predicting about 60% of the rows. We do have about 30% of them where the cat actually ends up being predicted as a dog. And so that gives us some good ideas on some potential additional data augmentation strategies you can use, but it could also indicate some mislabeling. So when you have 2 labels or 2 categories that are quite similar, training a model and seeing the different labels that are incorrectly predicted gives you an indication as to some of the challenges on like some of the labels that might have been incorrect. So that's kind of the single experiment view. It gives you a good idea on a single training run. So now let's take a quick step back and let's have a look at, now that we have trained multiple experiments and we have multiple training runs, let's take a step back and have a look at what's been happening across our different training runs. So now we've jumped to the experiment tab here. So we're kind of moving away from a single experiment to a set of experiments organized within a project, here the Yellow v5 demo. And we can see that we have trained multiple models, mostly varying the model architecture that's going to be used, as well as some different hyperparameters. So we've used a very large model, the large one, medium, small, and nano models. And we can see that, of course, as we would expect, the bigger the model, the more, the better it performs. And so we can see here all of our different performance metrics. But what we're actually looking at when it comes to choosing the model architecture is a balance, right, between the performance of the model, but also how long it took to train. So let me add the duration here. And we can see here that we have our different models. Some of them have trained very quickly, others not so much. And as the model gets smaller and smaller, the training runs become quicker and quicker. And so that becomes a good indication and a good way of choosing your model architecture. And once you've chosen it, you can start tuning your hyperparameters. So we kind of have this tabular view, gives us a good summary of what's been happening with our experiments. But really what we want to do is we want to jump to panels. So here what we can do is we can build a custom dashboard to allow us to understand exactly what's been happening with a model. So here we're looking at all of our different training runs. We have the best performing model. We can see how the model performed as it was training, right, as a function of epochs. We can also have some parallel coordinates chart to see how the weight is impacting the final accuracy metrics that we have, as well as the batch size. So we can see here that the batch size doesn't actually end up impacting final performance, but as you start tweaking more and more hyperparameters, that's definitely something that you'll want to consider. And then finally, we have here bar charts. A really cool feature actually of the Comet platform that I kind of want to emphasize a little bit is being able to compare any image between experiments, right? So what we can do here is we've actually added a panel that looks at the PR curve. That's again automatically captured, and we can see how it's changing as a function of our experiments. And we can see here, for example, this was for a very large model that we saw at the beginning. We have very few classes where we have both low precision and low recall when we start lowering that threshold. However, when we start going to some of the smaller model architectures that do train a lot quicker, we start seeing some of that appearing where for some classes, for example, boats, which is the red one down here, the model is just not able to learn that class as efficiently as a very large model. So that's kind of one way where you're able to summarize all of the information of all of your different training runs to be able to get a good overview of the model training flow. I can see in the Q&A a couple of questions around the key differentiators with some of the other tools in this space. And so let me highlight just one or two as we go through the rest of the demo here. So the first one that we have is the ability to create different views. So when you're going to be kind of tracking the training process, often you don't just want to look at some of these summary metrics. You might want to start looking at some of your individual predictions. And so what you'll want to do there is, let's switch to a different view. Let's add some different panels, some different visualizations. Let's potentially update some of the filters or grouping options. And let's have a look here. So here, what we've added is our new image panel, where we've taken a given image, we're plotting it, and each column here is a different experiment, and we can see how the different labels and our different predictions, well, the labels are fixed, but how the different predictions are changing as we're training the model. And if we see here at the bottom, it might be a little bit small, but what we can see is while the model is relatively good at identifying buses very early on in the training process, as soon as we start training more and more, it seems to forget about buses. And so here we can see that the more we train the model, the worse we get at predicting those labels. And so that becomes a really great way of being able to identify where your model is not performing as well, what's happening during the training process as well, all within the Comet platform. One of the things that I'd love to cover when we think about the Comet tool is we want to make Comet super customizable. And so what we have is we have the ability to add new visualizations to the Comet platform. And so here we have our line charts, scatter charts, a bunch of different visualization options, kind of all really easy to configure. You can here choose what you would like to plot, let's say as a function of epoch, and kind of all of that can be added to your dashboards. But what you can actually also do is you can create your own custom visualizations using Python. So one of the things that can be a little bit hard is all of this data is being logged to Comet, but sometimes you want to tweak it just a little bit. And so what you can do is you can use our Python panels that are actually written in Python. all of it running in the browser, using the data you have stored in Comet to be able to create your own visualizations. And so that extensibility of our visualization options is something that really sets us apart from a lot of the other tools out there, and something that really becomes super beneficial to the debugging process. Instead of knowing exactly which metrics you would like to track, what you can do instead is let's just log some additional data to the Comet platform, and then we're able to manipulate it in any way that we would like, create any visualizations that we would like, all while using matplotlib, which I'm sure all of us are very familiar with. So here I can just capture the thumbnail. We'll add here a new panel, and it's the 27th of September. So we can save that panel. We'll add a little screenshot, and then now that becomes available in our workspace. And we can see here lots of the different panels that we have saved, and you can start adding those to your Comet platform. So that becomes like a really powerful thing that you can do within Comet. So let's see, for the 27th, we have our new panel. I can add it, and also it's now becomes available here at the bottom. And what's really powerful about it is, let me change the layout a little bit, is that this panel automatically changes and is dynamic. As soon as you have a new experiment or a new training run, then this panel will update to show you that new training run within the panel. So you can kind of really think about it as a very dynamic Python visualization, all within the Comet platform. So that's kind of another big thing that kind of sets us apart from some of the other tools on the platform. I won't have time to cover everything, but there is another thing that I kind of wanted to touch on before I tackle any other Q&A questions. So here we have all of our different training runs. And so what we'll want to do is we have this Frightened Chalet training run, which is actually the best performing model out of everything that we have. And so we can jump into that model. We can jump down here to our assets and artifacts. And what we can see here is that we have actually logged the model for this particular training run. This is something we often recommend. And so what we can now do is we can actually register this model. We're going to be adding it to the YOLO v5 kind of model registry model. And so this is going to be version 2 of our model. We can save that. We can now jump to the model registry. We can see that we have our model here, version 2 of our model. We have the full lineage of that model. We know exactly how it was trained. We can use one of the integrations that we have built around, let me just clear the filter. One of the integrations that we have built using webhooks, for example, to trigger the deployment of this model and even monitor it all within the Comet platform. And so here we're going to change the stage for version 1 of the model. We're going to deploy version 2. This is going to trigger a webhook that will deploy our model. And now we have that kind of full lineage within the Comet platform. So the model registry, as well as production monitoring, which I talked about a little bit before, that unfortunately we won't have time to cover, are also a couple of other things that sets us apart from some of the other players in this space. But really the main thing is our customizability, extensibility, flexibility, as well as all of our REST APIs, our Python SDK, which has a lot of different methods, a lot of different things you can do with it. All of those are things that are kind of really core to the Comet experience. So that's kind of everything that I wanted to cover today. Hopefully that gives you a kind of good overview of some of the things that you can do to be able to either both visualize your object detection models within the Comet platform through visualizing its training data, visualizing the performance metrics, or even individual predictions, as well as kind of debugging all of those methods using our confusion matrix, for example, all of which are things that are built into the Comet platform. So yeah, thank you very much for joining, everyone.